Hello, this is Chris from the Motion Bench, and in today's video we will be building the A4T, developed by Armchair Heavy Industries. A4T stands for Another 4010 Toolhead. What you see here before you is the completed build of this, including the mounting bracket that will go onto the X gantry itself once we install it onto my printer. So without further ado, we're going to go ahead and get into building this toolhead. All right, and through the power and magic of editing, we now have a disassembled toolhead. So we'll go ahead and get started going over all of the individual parts before we begin building this. So when you first print this, whatever version that you get for your hot end, it's going to come with supports pre-enabled. So you don't have to enable supports when you print. For the fan shrouds, these will essentially print like this. Mine came off automatically when I removed it from the print bed, but it'll print like this. You don't have to enable supports. So we'll go ahead and discard these, and then we'll remove the rest of the built-in supports. Starting at the top here, these are the mount points for mounting it to your gantry. And just cut those little tabs off of there. They're just small little plastic, like bridging tabs, just like that. The next part we'll remove are the supports for the fan ducts, which these can be a tiny bit tricky to remove, but not really. They just kind of pop out of there like that. There's a little bit of leftover pieces that I can get out of here with a pair of tweezers. If you see this up here, that needs to be removed. Just like that, it pops out, and that's it. We'll do the same thing on the other side. Just get in there with some tweezers, pop it out of there, dump all little loose pieces of plastic out, and there you go. If your printer is precise, then it will come out pretty easily. The one issue that I've had with my printer specifically, and I don't know why the P1S has such trouble printing Polymaker ASA filament, but mine never prints the support for this particular side. I've printed this body housing 3 times now, and it's never printed this support correctly. That being said, it's always printed this little frame for the LED correctly. On the other side, it always prints the support correctly. So you just get in here with a little pair of tweezers again, and you kind of break that support out of there. This one can be a little bit tricky to remove. You just have to be patient, work with it. Just try to get in there, get a good little grip on it, and then pull it out. That's part 1 of that support. There is another part further inside. I don't know if I'll be able to show you on the camera here, but if you can look down inside this little hole right there, that's another little support that needs to come out. And again, just get in there with some tweezers, just kind of work it out. Trying not to use my fine point tweezers because I don't want to break them. And there you have it. Just a small little tree support like that. Should pop right out. Give it a good visual inspection. I won't be able to show every single part of like this interior support any better than I have, but you can look inside of these holes on both sides and just make sure that they're clear of any like stringy loose filament or any supports like that. I do believe that is it for the supports. The rest of it prints perfectly fine, just the way it is. And that being said, we'll get rid of this. We can discard the remove support material, and that's that. All right, next step we'll go over. This housing is specific to the hot end that you're going to use. The particular hot end that I'm using is the Rapido V2 ultra high flow, and this housing is specific to this hot end. Now there may be multiple hot ends that fit with this housing, but using the configurator on the website, this one is specific to that hot end. Anyhow, this here is just basically kind of like a duct cover to help keep that 2510 fan secure in place, and I'm assuming it probably helps with some kind of helps with the airflow as well, which is why it's shaped the way that it is. I don't have 100% certainty with that, but I assume it's designed this way for a reason. Here we have our LED lights. These are just little single RGBW, in my case, little chiclet LEDs or chip LEDs, 5 volt. There's 3 of those. This here is part of the package of files that you'll print, and we'll see how that slides in later. Then, of course, we have our 4010 fans, which is the name of this tool head, another 4010 tool head. So these will go in the two sides here and here. And then of course, 2510 fan. This is to cool the heat break of the hot end so that your filament doesn't melt all the way up and through here, and then it doesn't melt all your plastic and everything else. Now, this is not really specific to this Toolhead assembly video, but I will be mounting it to this. This is the Cartographer 3D Stealth Burner Toolhead mount in a 6mm belt configuration. I do also have the XOL Toolhead in a 9mm belt configuration. At some point when I'm building my printer, this will be my permanent mount once I get the full metal gantry and all of that. That being said, with this in particular, I had to shave about 1.8 millimeters off of the bottom of this in order to use it with any version of the A4T toolhead. I'm not 100% certain yet if 1.8 millimeters was enough, but that's the starting point that was listed on the GitHub docs for the A4T. This here is the Cartographer 3D Eddy version 4. This supports both USB and CAN mode. I will be running this in CANBUS mode, so we're going to have to flash this later. That'll be in a separate video. But yeah, this here is the WristWatch BMG for A4T extruder assembly housing. This is the other half of that housing. This goes together here. All your gearing and stuff goes inside of that. Speaking of gearing, this is an OEM all-metal set for the Sherpa Rapido V2. Okay, and it comes with these two sets of gears. This is installed by default. It's press fit. You cannot remove it. And then here we have our two bearings that will allow this main drive gear to, spin inside of the housing. We have these two little needle bearings and this shaft here. These needle bearings go on like so, and then you slide them inside of that gear, just like that. And then we have some various screws. We got an M12, M16, and an M25 here at the top. Then we have our thumb screw. This is for the tensioner. This here is the tension arm for the second drive. You can do this in an idler pulley configuration instead of a second gear. I chose to go with the second gear because I want the maximum performance I can get out of this tool head. Then we have our pneumatic valve system thing. When you buy these, they come like this, and then for our installation, we need to take this little black rubber grommet off the bottom, as well as this little piece of black plastic. It should just pop right out of there. We can discard those because we won't need them. Here we have the NEMA 14 36mm stepper motor. This one has 10 teeth. I do believe that this is compatible with 8-teeth motors as well. Here we have a simple end stop switch that's wired and normally closed. This will be our filament runout sensor. And we have a couple more screws here, 2 more M16s, and then 2 M8s. These here are some standoffs. I'll get into that later. They're just for mounting the toolhead board to the back of the motor. This here is the toolhead bracket that mounts on the back side of the motor. I'll show that later. And last but not least, we have the BigTreeTech EBB36 Gen 2. Now, this setup can work with the Gen 1, but I do believe that you don't get as many fan headers, and there's some other features, like, for example, I'm running this Cartographer 3D Eddy sensor in CAN mode, and I can plug this directly into the board, as opposed to having to run an entire separate USB cable down to my electronics hub. And I'll go over this in more detail in a separate video, including how to install Catapult as well as Klipper, go over all of the individual features. I'm not going to cover them all here, but this toolhead board does pretty much everything that I need. The one thing that I might do different from a standard install, though, is I have a 3010 fan with a little bracket that I can mount to the back side of this toolhead board with some standoffs. And what I'm thinking about doing is using one of these fan ports to power this fan when I'm printing. That way it'll keep this board cool. That depends on heat. If these little heat sinks do the job fine, then maybe I won't use this fan. If I do use this fan, what I'll end up having to do is tie these two part fans together in parallel and run them off of one fan header here. Okay. The reason for that is these are 0.1 amp fans, and I do believe that the maximum draw for fans is like 1.5 amps. So we're nowhere near that limit. And simply put, I only have 3 fan headers, and I have potentially 4 fans. I haven't decided yet, but I'm not going to use this in this install, but I'm just kind of throwing out the option out there. At any rate, I guess we'll go ahead and get started with the assembly. I'll start with the fans because there's some important steps that you need to do with these fans. Okay, so when you get your print file package and you print your files, you're going to come with these little backflow inhibitor pieces here. And what you're going to do is you're going to insert them right here where you can see I already have them inserted, and I don't have any other 4010s laying around to demonstrate this, but basically I'll do it on this side as if I'm going to do it permanently. So you're just going to slide it in there like that and make sure that it's flush. As long as your fan spins, then this backflow inhibitor is working as intended. That being said, if you're having issues or your printer's not is very precise, which to be fair, if you're going to print toolhead, functional parts like toolhead assemblies and things like that from your printer, it should be precise. Either way, if you're having trouble getting this backflow inhibitor installed, of course, I'm showing it on the bottom just because I've already got one installed on the top. Don't install it on the side of the arrow because that's the direction that the air flows. The idea is to keep air from pulling back up into this side so that you have a single channel of air blowing out with nothing being sucked back up in. Okay, and you just kind of slide it in there. You glue a little drop of super glue to secure it in place. You break this little tab off, and then you basically hit it with a little bit of sandpaper or a file. Make sure it's all flush. That way there's no overhangs or anything like that. So it'll go into the housing body here correctly. And you'll do that for both fans. The setup for both fans is exactly the same because the airflow on both fans is the same. Don't install it on the side with the arrow, install it on the opposite side. I guess real quick, just to cover it, if you're going to use this little spacer to help you install the backflow inhibitor, you do need to remove the top plate of this fan. I didn't want to do that just because I don't want to risk breaking it. These are the only two 4010s I have at the moment. And I really just found that I didn't need to either. There's plenty of clearance in there to install them without taking this, prying this top shell off and, using this to guide that. So if you don't need to, I don't think you need to. Anyhow, I guess without further ado, we will actually start assembling this thing. And to begin assembling this thing, we have to start with the LED diffuser. Now, all of my parts here that you see, anything black and purple that's printed in Polymaker ASA. This little white looking piece, which is, I guess you might as well call it white, but it's natural color ABS. That's the only thing that's different. Everything else is in ASA. You take this diffuser and you want this to be in a translucent color like white or natural ABS color because you want light to be able to shine through it. And then you're going to take this little black cover, it's kind of acts as a frame around the top of that. What I'm going to do is put a little drop of super glue on there just to keep it all together so I don't lose it or drop it. I'll just hold it like this. And then right on that thicker edge, I'm just going to put a little tiny drop of super glue on the top, just like that. A little tiny drop over here, just like that. Don't need a whole lot. I'm using a very fine tip of my CA glue. We'll take this black piece, set it on over top of there, press it down, make sure it's aligned because it may not fit exactly perfectly onto it. It's a little bit loose, but just like that, it should be good to go. Just for this process, to help it speed up, I will hit it with a little bit of activator spray, just like that. That'll set the glue instantly, and now I don't have to worry about it coming apart. I'll wait for that to dry, and then this slides in here like so, the pointy triangle side upwards, and it just slides in there like that. Now I'm going to put a little drop of super glue on there just to kind of keep it from falling out. When you're fumbling around with the LEDs, this has a tendency to want to bounce around and fall out. All it takes is a little drop of super glue. I'll put one right here on this side and one right here on this side. Tiniest little drop of super glue. And then I will now use my tweezers because I don't want to get glue all over my fingers if I can avoid it. And I'll slide it right in there, let it fall into place, press it down with my tweezers. Should set pretty quickly since I used a very tiny amount. But either way, all we're trying to do is prevent it from falling out when we're working with the LEDs. I got that in there. I'll hit it with a little bit of activator spray, maybe from, I don't know if it'll get down in there, but just a little bit of activator. Let that evaporate, and we should be ready to go. So, to speak about the LEDs real quick, in the docs for the A4T, there are guidelines for how long each wire should be. I'm using this silicone sleeved 24 gauge wire. For my application, this works pretty well, albeit it is a little bulky because of the silicone sleeving, and it's a little bit more tricky to, you know, route the wiring and get it to all stay into place, but I prefer it. It has a little bit more temperature resistance than your standard wire, and more importantly, it's pretty much the only wire that I have laying around at the moment. I did wire these myself. Also, if you're wiring them yourself, you need to make sure the orientation specifically for this middle LED. You want both sets of wires soldered onto the board so that they're both going away from the board, even though the orientation of the wire is still, so this side is in and then this is out. But you want the wire itself and then the subsequent LED, you want it to come off of the board in the same direction that the one you soldered for the inlet is installed. So after much trial and error, I figured out the best way for me to install these, or the simplest, easiest way, is to start with the middle LED first. Install the little holding bracket onto the LED that goes here, which is the first in the chain. And you want to slide this through to where the LEDs are face down. So this main LED, or the central LED, is face down, and then we'll start working that middle LED through this hole, pull it through, keeping our wires straight and untangled. We're going to pull that through just like that. And then once we have that second LED through, now we can grab our tweezers and grab the wiring for that loose LED, the last LED in the chain. Okay, and we just start pulling that through. Once we get enough pulled through that we can get our finger on it, we just want it to kind of be flat as we work it through here, and then just like that. Finally, for this step, we just line that little plastic bracket up and push it into the housing, just like so. Once you push it all the way down, it will secure into place. It'll kind of click into place a little bit, just like that. And then you can see the housing of the LED housing and that little lip on the bottom of the body are touching. So it's a mated surface. That way you'll know that that is installed correctly and all the way. From there, we simply twist it so our LED is pointing upward. We get our wiring straight, sorted the way that we want. I'm going to pre-run this one over top of the other one on the right side, like so. And then those little notches that we saw earlier where we removed the built-in supports, there's little notches for each side of these little chiclet or chip style LEDs, and you just have to kind of line it up with that. And then once you get it lined up there, it'll look more or less like that, if my camera will focus on it. Come on, focus. So it'll look pretty much like that. And then from there, if you got big hands like I do, you can take your tweezers or a tool and just kind of start pushing it in there. You want to make sure that the square LED is lined up with the square hole and that it's straight. I'm actually going to take one of my hex drivers here and help use that. It should be a little bit tight, but it'll pop in there just like that, and everything's perfectly aligned. From there, we can move this little bit of wire. You know what? Actually, I'm going to lift this wire up and I'm going to run this one up underneath that and back out the other side. So just pull that through like so, get a hold of it, pull it up there, and boom, done. And we can just kind of push that little short strand of LED out of the way just so it's not visible from the front. You don't want that wire sticking out. And then from there, this will wrap around, this LED will wrap around that internal little body here. What I'm going to do is first take this LED and install it into the spot where it goes, which is identical to the other side. There's a little notch cut out to get that in place. Once you get it lined up in there, you can take your finger or a little tool. I'm using my hex driver here and just kind of work it into place. Be careful when you're installing these. You don't want to force them too hard, which of course I'm having to do here. If you do have to, put some effort into pushing them in there, just make sure that you don't slip and damage any of your electronics on the board or the LED itself. But once it's in there, it should look just like that on both sides. And now we've got this wire to work around. I'm going to just kind of work it around with some tweezers, get it up under those little tabs there on either side. Doesn't have to be perfect. Again, refer to the guide on the GitHub page for this toolhead for how long to make these LED wires. I do know that mine are slightly ever so slightly too long, but at the end of the day, you can get away with it being a little bit too long versus being a little bit too short. So once the wire's routed, just like that. Also, you probably won't have as much trouble as I'm having getting these wires here. Again, mine are a little thicker than what you're probably going to be dealing with. Standard 22 gauge or 24 gauge wire. And that's only because of this silicone sleeving that's on the wires. But either way, once it's there, it's done. Now we'll take this main lead wire. This goes up to the toolhead board later. As you can see, all of my wires are already pre-cut. I did build this out first to make sure I did everything correctly. And what I'm going to do is grab our 2510 fan. Now, there is but a single photo in the documentation for assembling this part of the toolhead, and it shows that the wire for this fan is kind of installed in that orientation, where the wire comes out of the fan up here. The problem that I had with that is, for my specific mount, so this mounts initially to this bracket like so. You got these two M3s on here, and then they'll slide on like that, and then you'll reach in here with your hex driver, you'll slide that all the way through, and then you'll tighten those screws down, and it'll cinch it down. It'll cinch this body down to the bracket here. If I run the wire the way that it looks like in the photo of the docks, then what'll happen is I won't be able to get my screwdriver up in through this side, because that fan wire will be blocking the hole needed to get my hex driver up through there. Also, on my particular board, which is going to be sitting up here, the fan port for that is here. So it's kind of counterintuitive to run the wire up out of this side, up the right side, or, you know, from this side it's the right side, but from the front it's the left. But it's a little counterintuitive to run that fan wire up through here and then back across the board to the other side. So then upon inspecting it, and maybe it was made like this on purpose, and maybe I just didn't notice it before, but if you look down in here, there's this little notch here that looks like it's perfect for wiring. And when we install our fan, that's actually a perfect little spot for those wires to come out. And then they can run right up the side of the toolhead and go, or the shroud here, and then go right into the toolhead board. So once installing this fan, you're gonna put it in there kind of at an angle with the front side down. There's going to be these two little notches on either side there that the top edge of the fan needs to be underneath of. Word of caution, okay? These fans are very fragile. If you try to push the fan in there by pressing on this sticker, you will break these little tiny plastic pieces of the body that mount this circuit board and the fan blade itself to the shroud. Do not press from here. Press from either of the corners of the main body or the edges. If you press from here, you're going to put your finger right through it. That's going to snap off, and now you have a useless fan. So be careful. Take your time working with this. There's no rush. Take your 2510. Make sure that these wires stay in that little notch, and then you can push it into the housing like so. And when you look in there, you'll be able to see that the wires are running exactly where they need to be. You want them up under this little lip right here. It's hard to tell, it's hard to see. Once you get that wire in and you're certain that it's in the right spot, you just you put it in an angle like so. You pull this wiring out of the way, and you just kind of start to work the body down, the body of this fan down, and seat it into place. It can be a little bit tight, especially if you're using big wires like mine, but it's the help of a pair of little tweezers here. And kind of push these wires down out of the way, just like that. Now, I do have a couple wires here. Still need to push these down. It's easy enough. Just take the bottom of my tweezers, push them in there. And again, when you're pushing this fan in here, please do not push on the sticker part. Push on the outside edges. And just like that, should go into place. The wiring here is good. Everything there is good. Just be careful and take your time when you're pushing that into place. You don't have to force it down. You don't have to press it aggressively hard. Just make sure it all goes into place. There we go. And that'll help hold that fan in there as well. All right. From there, so we're going to take this hot end fan duct. We're going to line it up. I mean, it's kind of self-explanatory, but there's those little legs. These little notched parts on the these on the bottom side, those go down towards the LED side. And you just kind of hold your wires out of the way, and it'll start to set into place just like so. And then those little tabs there on either side, they'll slide up under those arms on the main body. And then when you're pushing it, it's going to want to kind of go either left or right. It's going to kind of want to slide one way or the other. The idea is to just kind of get it in there in a central way. Once you get these, you know, these little corners here up within this rounded off portion, it'll be easier to slide in there, and you just kind of push it in place until it locks in. And we can give it a little bit of a, just squeezing it a little bit, make sure it's flush up against there. Everything looks good. I don't know if it's supposed to go all the way up in there, but it doesn't seem to want to. But it looks like it should. So I'm going to set it down here and try to give it, there we go. Now it locked into place. Now it's more centered on the back of the fan. That being said, that's it. Next thing I'm going to do, I'm going to pull this wire up through here temporarily. And then I will take this LED wire, and I'm actually going to drape it across the front of that little notched out section right there. For my application, it tends to fit perfectly doing that. It's a little bit snug, but it works. So I'm going to get this set up like that. That wire is going to drape across the front just like that. It comes in behind where the 4010 will be, so it's not going to collide with it on that side. And the 4010 will actually sandwich it in there and kind of keep it from bouncing around inside of the housing. Then I'll take one of my 4010s, be careful, or just be mindful. This is the duct. You want the open end part facing the duct, just like so when you slide it in. Of course, you want the blades facing outward to the hole, and then it just kind of press fits in place. It doesn't, there's no screws, nothing like that. And I'm just pushing these wires flat up against that surface until I get the fan to slide over top of it. Just like so. Make sure my hot end fan wires are out of the way, and then just push it in place until it's all the way in. It doesn't really click into place, but you'll know when it's seated. It'll be flush with the back of the body here, and the fan will be centered to the hole, and just like that. Now we will do the same thing on the opposite side. This time, this wire will fold up the back of there. If you look down inside, there's a slight little cutout right there underneath my pinky. That's where the wire for this goes. You'll slide it in just like that. Noticing again the orientation of your duct to the duct of the main body. And then you just push it down into place and boom, just like that. Our fans are run. All that's good to go. Next step is our hot end. So we're going to take it. The wires will come out when it's facing you like this. This is the right side. When it's turned around, the way that you'll see it on the printer, this is the left side. From here, the wires will want to come up the right side because on our board, our hot end is right here and our thermistor is kind of right there in the middle. Also, we already have quite a few wires coming up the left side from here, so we don't want to overload either side with more wiring than we have to. From there, we just kind of look through the top here and get our screw holes lined up, which is right about there. I'm going to hold that in place. You should be able to, if you can kind of tell, you can see the holes there. They're not perfectly aligned yet, but they're good enough for me to get one screw started. I hope. Yep, I can feel it threading in there. And now it's still loose, which will allow me to adjust this back and forth as needed to get the second screw in, which I'll do diagonally across from the first one. Once I get that starting to thread, now I know that pretty much it's lined up. And then I'll put my other two screws in and start threading those, just like so. I'm going to thread them all down. We're not going to tighten any of them just yet. Just getting them all started, and then we're just going to go right to snug with all of them. From there, I go in a crisscross pattern. So I'll start with this one. I'll tighten this about a quarter turn past snug. Then I'll skip to this one. Then I'll do this one, and then I'll do this one. Once I do all four, I'll come back again and just double check them. I'm just using my fingertips. There is no torque spec to these. Don't crank them down. Don't over tighten them, but you want to make sure that they're tight enough to where nothing's going to move or rattle. Later on, once I test this and make sure everything works, I'll go back through, disassemble this whole thing, and anything that has screws on it, I will put some Loctite on. So I'm just going to take it like so. I'm going to go about a quarter turn past snug. Then I'm going to come across to the other side, do the same thing. Basically what I'm trying to do is put the same amount of pressure on all four screws. We'll run all these wires up. This side will zip tie down to there. There's a little zip tie point here and a zip tie point here. Once we get our extruder all assembled and ready to install. But for now, that is the hot end side of this entire tool head. Time to move on to the extruder side. Extruder side is pretty straightforward. These bearings will be specific to your main drive gear. Some of them that I have with the plastic teeth, they have more narrow center drive shafts, and they're going to have a different size bearing. But essentially, one bearing goes on this end. Don't force your bearings on there. If you have to force them, take some sandpaper to the post and like try to file it down a little bit. Because if you try to force your bearings on there, you'll damage the insides. But essentially, it's like that. And then once it's in the body of the extruder assembly, it will be able to spin freely. You can take this and put it on here and then start to slide this through the main body here. And then try to work that bearing into the cutout for it on the plastic body here. And it'll press into place. Don't overdo it. And then once it's in here like that, this can now spin freely. Okay. The next part is basically the same for the other side. We're just going to take this. It's going to go on there like so. Just kind of line it up a little bit, press it on there, and now you can remove this side. That bearing is set. Press it down in there all the way. Set it on the flat surface and just kind of push it down until it's flush. And that's it. Now we're going to pull this main drive bearing back, our gear back out of here, because we need to install our end stop switch. End stop switch consists, or the filament runout sensor switch consists of three main parts. You've got your 6x3 magnet here. You've got this little printed part that comes with your files here. And then you have the actual switch itself, which is here. Now I'm going to zoom in a little bit and just explain how all this is supposed to go together. Okay. Basically, if the body is sitting like this, in this orientation, you're going to insert the magnet first, and then you're going to install this little plastic piece, okay? And there's a specific shape to this plastic piece. You want that longer little ridge on the bottom, you want that to be facing just like that, and it's going to set up against that magnet, and you want that to be oriented towards the center of the main housing. And then from there, this little end stop switch will install inside of here. You'll screw it down in those little holes with some M2s, and that will act as your filament runout sensor. So then if we take our filament, when we push our filament through here, when everything's all assembled, it's going to come through here and through here. As it pushes through this side, it will push this magnet back up against this plastic, which will then push it back up against the switch, activating the switch, letting you know that there's filament, or letting this, the system know that there's filament in there. And I'll demonstrate that once I get it all together. So the easiest way that I found to get this magnet in that little cutout notch inside of there is to put it in there and just kind of bounce it around until it falls in there. Now with this one, because we want it oriented in a specific way, I'm going to use a pair of tweezers to slide it in there. We just want it facing like this, just like that. And then we're going to slide that in to that little cutout there and let it fall into place. You don't want to use any kind of super glue on this spot. That magnet and that little piece needs to be able to move freely. From there, you take your end stop switch and you get it down in there. There is a little notch cut out inside of this housing for it to sit flush up against the body. So we just need to work it down in there until it sits flush, pretty much like so. Once I put some screws in there, it'll be secure. It'll be mounted properly and good to go. I have some M2x10s here. Now these are supposed to be self-tapping screws, but I don't have any self-tapping screws, so machine screws will have to do. And then I'll just start threading them into the pre-cut holes. You do not need heat inserts or anything. Just take your time, thread it through. Don't go too fast so you don't strip it out. You don't need to tighten it overly tight, just enough to keep that from moving, just like that. So that's one screw tightened. Then I'll go through and do the next one. And then I'll take a look at everything, make sure it's all in there the way it's supposed to be. I'm going to set it down on here and just kind of press down as I'm screwing in. Just make sure it feeds down in there the way it's supposed to. Again, if you have self-tapping M2s, by all means use them, but I don't. So now All of that's in place. We're going to feed some filament down in here. And I don't know if you can hear that. That's the switch activating, telling the system that there's filament in there. And it just goes through just like that. Hopefully you can hear that clicking, and just like that. Now, once we get that end stop installed, we can move on. From there, we need to route our wire for our end stop filament switch. And then again, my wires, this is the same wire that I use for the RGBs. It's the wire that I have handy. It's a little bit more difficult to work with than your standard wire, but I'll make do. You just kind of push it down inside of this little groove. There's a cutout specifically for this, to, this wiring. I'm going to push this down inside of there. I'm not overdoing it. I don't want to damage my wires or cut them or break the shielding, but with a little bit of patience, they'll go in like that. You'll notice on mine, because these wires are still stuck together up here, I have one that's slightly longer. All I really need to do is just grip it inside of the housing and pull some of the wire back through into the housing until they're the same length like that. And then we just want to make sure that the wires are not sticking up, potentially coming into contact with the main drive gear, and boom, it should look like that when it's done. Now we can install the main drive gear. It should just slide onto your bearing like so. It should spin very freely. Then we take off the back side of our housing, print it in our accent color of purple, and we just kind of press that on there, making sure our wires are not pinched, that they feed through the channel. All of that should go on there really easily. We're going to take one of our M3 square nuts and we're going to press it into place here. It's a little bit tricky to get it flat. So one little thing you can do is get yourself an M3 screw, thread it into the nut, and then use that to help push the nut in place so that it goes in flat like that. And then from there, just kind of press the nut into place. And then we can take our tension arm here, take our other gear. This can only go on here one way. The teeth side of the gear go on this side. This side is what grips onto the filament. You line it up and just snap it into place, and now it spins freely. Okay, so what I'm going to do is take one of these 0.3 millimeter shims and I'm going to install it on top of there like so, and hopefully that'll give me enough clearance from this back housing to where I won't get any binding from my main gear. There we go, that seems like it'll be better. Alright, so you may or may not need to use some shims. My extruder kit came with some shims, so that little 0.3 millimeter shim seemed to help quite a lot. Back to the installation. We're going to install our motor before we actually install this arm, just to make it a little bit easier. So again, I want my wire to be down this way. I'm going to get that gear in there, push this top one through, and begin threading it into the motor bracket, just like so. Just to snug, I can still adjust the motor here as needed. Let's get our M12 screw started because we don't want to over adjust. So we'll drive our M3x12 screw in here. We're not going to tighten it down at all. We want this arm to be able to move freely. And then from here, we're going to take and adjust our motor position here. So if you look here, there's too much of a gap between the motor gear and the main drive gear. What we want to do on the opposite side of that, there's no gap there now, and that's too tight. So we want to back it off just a touch to where that there's a tiny bit of gap and the smallest little amount of play, like so. Should be able to see that main drive gear moving back and forth. That is about perfect. So now what I'm going to do is come in here and tighten that second arm down just a touch. Double check our clearance. We still have that tiny little bit of play, which is what we want. We'll come back up here again, snug. So we're going to go snug and just a little bit tighter, about quarter to a half turn. It just depends on, how well your layer inside of here is. If it smushes down a little bit, that's fine. You don't want to over crank it again. I'm just using my fingers to kind of help gauge the torque. Then we'll come back and we'll do the same thing with this one, just like that. You especially don't want to over tighten this one because that is a relatively thin piece of plastic. And if we come back, everything is adjusted and we still have that tiny little bit of play right there. From there, we can take our tension arm, set it into place like so, and then take our M3x25 screw and push it through just like that. And then we will thread that into the M3 nut in behind the housing, like so, down to snug, and just like that. We want this arm to be able to move freely, and then once you close it, it'll look like so. You take your other M3 square nut and you're going to press it down into that little notch there, like so. You can use your little hex driver to get it all the way down there if you need to, just like that. That nut, as far as I can tell, should not fall out if I hold it upside down. It's kind of press fit in there just a touch. It's not super tight. Then we take our M3 thumb screw. I believe this is M3 by 20. And we're going to thread that in there. We're not going to worry about the tension just now, but this is, it's a spring-loaded arm. It acts as a tensioner. That's what it looks like assembled. The next thing we're going to do is take this little gray piece for the pneumatic fitting, line it up inside of that hole on the top, and just going to really like press it down into place until it snaps in, just like that. And then we'll take the little blue part. We'll try to line that up to where it's sitting flush. And then same thing, just snap it down into place. It can be a little bit tricky to get in there, but boom, just like that. Oh, you know what I forgot to do? I'm actually going to take this alignment bolt out, so I'm going to have to redo my alignment. I'm just going to pull it back ever so. I'm not going to take it all the way out, but I want to pull it back there because this is painted black. BigTreeTech recommends that you ground this board to your motor. So I'm just going to take my little sandpaper and I'm just going to sand it away like so to expose the bare metal underneath. And there, it should look just like that. That gives us a nice grounding point. I'll go ahead and tighten this back down to just snug. Double check our play. We got the perfect amount of play in that main gear. Close this again. Sometimes this can be a little bit tricky to close all the way because the gears won't line up perfectly. But boom, just like that. Put our thumb screw back in like so, just so we don't lose it. And there you have it. If you use this EBB36, either Gen 1 or Gen 2, they will come with brass standoffs. I don't like the color of the brass standoffs, so I just bought some standard M3 standoffs from Amazon. And they're just going to thread onto the back of here. I'm going to take the first part of my ground wire for the EBB board. I'm just going to set it down on that screw, tighten it down. And now that I have this standoff tightened down, the metal from the terminal here will contact the metal that we've filed or sanded away the paint from the motor, and that will give us a good ground. From there, we can take our board mount. This does require two M3 heat inserts. These are M3 by 4 by 5s. And you want to make sure that the top of this is oriented the same way because this is where my cable chain will go. We're going to install that here. First screw on this side, and then we'll tighten that down to just snug, and then we'll get our second M3 by 6 and put it on this side. Now you'll notice that this has the same kind of little notch as our motor mount. And the reason for that is wherever our motor mount adjustment is, we want to make sure that our board mount adjustment is the same because we want this to be facing up and down, this here to be facing up and down as much as possible. So once that's in place, we'll just tighten that down like so. That's nice and snug. This will not really be a moving part per se, so this doesn't have to be super tight. Same thing as everything else, just put a return pass snug. From there, take our EBB36, and I'll start with this screw on this side first. Start threading that in there like so. And before I crank it down all the way, we'll take our little ground wire. We will get our other M3. These are M3 by 8s. So then I will get that lined up with this hole. I'll get it installed just like so. Come on, stay in there. There we go. And then I'll start threading that in. And as that tightens down, it'll cinch our ground wire down to the grounding pad of the board, which then contacts everything else on the board. I suppose I could go through and try to make this like so. Tighten this back up like that. And that way it's not so unsightly. I mean, it's still not beautiful, but it is what it is. It serves a purpose, and that's all that matters. We can take our main motor wire, our pin, that connects up here. Now it's not dangling anymore. Just double check both of these. Good to go. This here is our filament runout sensor, and just let me pull up my pin out real quick. Filament runout sensor is this connector right here. Oh, it's this one. This connector right here. So we're going to run our filament runout sensor up and over the top of the board, and then down into that connector like so. And there you have it. Good to go. We'll go ahead and install this body to here. You're going to need 2 more M3 square nuts, and it's kind of important that you do this before you zip tie your wires down, because the inserts for the square nuts is there and the other one is here. And you'll just take your square nut. What I'm going to do is hold on to it with a pair of blunt nose tweezers, move my wires out of the way, put it in that hole, and drop it down. You'll be able to see the threads in there ever so slightly. If it doesn't drop all the way down, just use some tweezers and push it down. It could be a little bit tight. And then we will do the same thing with the other side. Slide it there, drop it down, check the alignment. I can see the threads, good to go. And then from there, make sure you don't forget your PTFE tubing. It doesn't matter which side you install it in first. Slide it into place and hold it. You're going to take your 2 M3x16 screws. Now I opted to have a washer on mine just because I want to make sure that there's even pressure there. So I'll get this one started first, and then I'll work on the other side. You might need to kind of thread that down past this little lip here, and once it's there, you can push it down and start tightening it down to the main body, like so. So then we'll do the other side. We'll get our M3x16, start screwing it down. It will catch. It looks like it does look like it might be short, but it will catch. And we'll just crank it down to snug, and then about a 1/4 turn, flipped over to this side. We'll go to snug, and then about a 1/4 turn as well. Come back on this side. Make sure the torque is about the same. Like if I'm twisting it like this on this side, it doesn't move. I know I'm good. If I give about the same amount of pressure on this side, it doesn't turn. I'm good to go. All of my wires are already pre-made and pre-cut. If anyone needs a specific video on how to cut and crimp and pin wires, let me know in the comments and I'll go through and do that. Next up are 2 fans on the outside. This fan header here and this fan header here. They're the two pin fan headers. We've got these jumpers installed for 24 volts and 24 volts. For our particular Hotend fan, we're going to use this 3-pin header here, and we have that configured to 5 volts. And then from there, we just kind of start plugging everything in. We can take our one fan here, like so. Take our other part coolant fan here, like so. Take our Hotend fan here, like so. We're just going to install that into place. And then we will take our LED RGB and we will run that across to this side of the board, underneath of that. And that's going to install on this side. And then our Hotend wires will go here and here. Now you are supposed to use like little butt connectors. I opted to just solder the tips of the wires. It serves the same purpose and it's a little less bulky. I've never had a problem doing this. Don't just put bare stranded wire through there, because as you tighten these down, you can pinch the wires off. If you're going to use bare wire, make sure that you put some solder on the tip. And then again with that, we're going to set it all up like this. We'll run some zip ties to everything, tidy it all up. But that being said, here you have it, the entire completed extruder assembly. In the next video, I will go through getting this actually on my printer. I'll show it set up. My printer's kind of in disarray at the moment because I'm in the process of tearing it all down completely, and I'm going to rebuild it into a 0G Nebula frame. I have that entire frame kit as well as the acrylic panels. I bought them from KB3D, and then I'm going to rebuild the entire printer into that, and I'm going to document that whole process. This is a new tool head that I'll be using with that new printer, and that's basically what it all looks like. I'll grab a couple of zip ties here just to show the completed build with all zip ties and everything in place, looking all nice and fancy like. There you have it. This is the completed build of the A4T, another 4010 tool head, with the WristWatch BMG extruder. Thanks for watching. If you like my content, please consider commenting, liking, and subscribing. And stick around for part 2 coming up in a few days. I will go over all the features of the EBB36. We'll go over the programming, flashing of Catapult and Klipper. I'll set it up in CANBUS mode. And then I also need to flash the Cartographer board because by default it ships with USB firmware. We need to flash it over to the CAN firmware to use it in the setup that we're going for. But that's it. Thanks for watching.